Hello there, this is an Algebra 2 video. It is Chapter 5, Section 1, and today we are talking about operations with polynomials. And before we can get started, I need to give you a little bit of a review of properties of exponents, because obviously polynomials have exponents and sometimes you have to be able to simplify expressions before you can get started. So this should be reviewed from Algebra 1, and so first and foremost, we have our product of powers property. Basically says that if you're multiplying the same base, then you add the exponents. Quotient of powers says that if you are dividing the same base, then you subtract the exponents. Of course, that's provided that x is not equal to 0, because you can't have 0 on the bottom of a fraction. You have the negative exponent, which sometimes gets confusing, but if you have x to the negative a power, then you can make it a positive power by reciprocating it. So this would be 1 over x to the positive a, or if it's on the bottom already, x to the negative a on the bottom, then you can reciprocate it, in other words, bring it to the top as x to the a, and again, because the x is on the bottom here, you want x to not equal 0. A power to a power is when you have x to the a, and then that in turn to the b power, and in that case, you multiply the exponents. We have power of a product, which is basically the distributive property. If you have two different bases being multiplied inside parentheses to a certain power, then you can distribute that power to both of those variables separately. And then you have power of a quotient, same idea, only with division. If you're dividing two different bases with the same exponent outside, you can distribute to the inside. And again, x can equal 0. But even more importantly with this guy, is that if you have a quotient and it's to the negative a power, then you can actually reciprocate the inside. So you'll notice that here the y went to the top and the x went to the bottom, but the exponent is now positive, and which in turn means that you can have y to the a over x to the a. And again, in this case, you don't want x or y to be 0 because you have those potentially on the bottom. And then our last one is the 0 power, which basically says that x to any base to the 0 power is 1. And again, as long as x does not equal 0. 0 to the 0 power is not 1. 0 to the 0 power is just 0. But any other number to the 0 power is 1. So we're going to get started with some examples here. And the first thing we want to do is to simplify each expression. And we're going to assume that none of the variables equal 0, because of course that would be a problem. So we want to make sure that we get that out of the way. None of our variables are 0, so we're going to go ahead. And one of the things that students get mistaken sometimes is that they don't realize that all of this is straight multiplication. So when I see 2 times 3, I can go ahead and deal with that first, and that's just going to be 6. Then I have a to the negative 2 times a cubed times b squared times c to the negative 2. So I get my a's and I put them together, and then here's my b's and my c's. So remember that when you have the same base, which in this case is a, you can add the exponent. So if I add negative 2 plus 3, I'm going to get 1. So 6a to the 1 power, the b squared, and my c has a negative exponent, so I want to reciprocate that, or basically bring it to the bottom and make it a positive exponent. Alright, so this would be my answer. Now remember that when you are simplifying expressions, it's not fully simplified unless there can be no powers to powers. So like part C, where you have a power to a power, that's not simplified. You shouldn't have any negative exponents. Each base should only be there once. So the a here, that there's 2 different a's, those need to be combined, which we did. So you can't have like this idea where you have 2 different q's, 2 different r's. You only can have each base one time, and of course all fractions need to be completely reduced if possible. Alright, so just want to make sure that you understand how you know that you're done. In this case, we're going to say that we have q, and because there's a q on top and on the bottom, this is division, we can say 2 minus 7, and then r is going to be 4 minus 3. I'm going to subtract the top minus the bottom. So when I do that, 2 minus 7 is negative 5, and then 4 minus 3 is 1. And since the q still has a negative exponent, I need to move that to the bottom and make it positive. So I get r divided by q to the 5th power. And that's how I simplify the second one. And the last one is kind of going to use the distributive property and also the power to a power property. Because basically everything inside this parentheses needs to get that 3 distributed to it. So we're going to have negative 2 to the 3rd power, a to the 4th to the 3rd power, divided by b squared to the 3rd power. So everything gets the 3 distributed to it. So negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8. So I get negative 8, and then a power to a power means that you multiply the exponent, so 4 times 3 is 12. And here again, 2 times 3 is 6. So this would be my final answer. So now I would like for you to try these on your own, and then we will move on to our next thing. And our next thing is talking about degree of a polynomial. Okay, now it's very important that you understand that each term of a polynomial has a degree, and then you have the degree of a polynomial of the whole thing. All right, so just a couple of hints here. How do you find the degree of a polynomial? First of all, terms. We've got to talk about terms. Each of these examples in part A, this is 2 terms. You've got 1/4 x to the 4th y cubed. That's all one term. This is not 3 separate terms. Terms are separated by addition and subtraction. So since this is subtraction, it's separating this term from that term. But 8 and x to the 5th is connected by multiplication. So 8 is not its own term. X to the 5th is not its own term. It's just all one term. So you have 2 additions here. So this is 3 terms. You've got 2 additions here, so this is also 3 terms. So you've got 2 terms, 3 terms, 3 terms. So it's important that you know what the terms are. And then you have to find the degree of the polynomial, because the degree of the polynomial is basically the term that has the highest exponent. Whenever you have 2 variables together, you have to add those exponents, and then that determines the degree. So for example, the degree of this term is 5. The degree of this term is 7, because 4 plus 3 is 7. So since this term is bigger than that one, then the degree of this polynomial is 7. All right? And it says determine whether each expression is a polynomial. A is a polynomial, and its degree is 7. Now in part B is not a polynomial because we don't consider fractional or negative exponents as polynomials. So this is x to the 1/2 power, and so we don't include that in polynomials. This is not a polynomial. And then over here, same thing. This is not a polynomial because it's got negative exponents. All right. So the only one that's a polynomial in our example is A, and the degree is 7. So now I need you guys to look at A, B for do-it-yourself number 2 and determine whether or not it's a polynomial first and foremost, and then if it is a polynomial, then tell me what the degree of the polynomial is. All right. And then we're going to do some more simplifying of expressions, but this time pretty much with addition. And that's actually pretty easy to do. You can combine terms as long as they have the same variable and the same exponent, the same degree, okay? So I can combine x squared with x squared, I can combine x with x, I can combine constants with constants, but I can't combine x squared with x's. So basically what I'm doing here is 4x squared minus 2x squared. Now if you want, you can distribute and go negative 2x squared minus 3x plus 1. A lot of people forget to distribute the negative to everything. So negative times positive is negative, negative times negative is positive. So then you can combine them. 4x squared minus 2x squared is going to give you 2x squared. Negative 5x and negative 3x is going to give you negative 8x. And 6 and a 1 is going to give you 7. So that would be your simplified answer. Over here we have addition, so we don't have to distribute addition, but we've got 6x squared and negative 4x squared. We're adding them together. So 6 minus 4 is actually 2. Negative 7x and a positive 9x is going to be 9 minus 7, which is 2. And then 8 and negative 5 is going to give you 3. So 2x squared plus 2x plus 3 will be our final answer for that one. And so now you can try do each number 3. Remember to distribute the negative here, and then you will be good to go. In example 4, we're going to actually be simplifying, but this time with distribution, because we're multiplying 3x times 2x squared minus 4x plus 6. So in that case, I'm going to slow it down just a little bit and show you that you basically have to go 3x times 2x squared plus 3x times negative 4x plus 3x times 6. So I'm taking 3x times each term here individually. And so as I said earlier, these are the same base, x and x. So this is an x to the 1, this is x to the second. So our property says to add the exponents. 3 times 2 is 6, so you get 6x cubed because 2 plus 1 is 3. In this case, 3 times negative 4 is negative 12. And x to the 1 and x to the 1, you add 1 and 1, you get x squared. 3 times 6 is 18, and then you have your x. There's only one x there, so you get 6x cubed minus 12x squared plus 18x. So now you can attempt to do it yourself number 4, and then we will move on to a little bit of a word problem here for you. Excuse me. It says the U.S. Department of Transportation limits the time a truck driver can work between periods of rest to 10 hours. So they can't work more than 10 hours. For the first part of his shift, Tom drives at a speed of 60 miles per hour. So that's going to be basically, if x is the first part of his shift, he's going 60x. 60 miles per hour, and x is the hours. For the second part of this shift, so he's going to have a second part to that, he drives at a speed of 70 miles per hour. But the question is, how many hours are the second shift? Well, we know that the total shift can only be 10 hours. And if this is already x, then this would be 10 hours minus whatever x is. In other words, if the first shift happened to be 3 hours, then he would only have 7 hours left to work the second shift, because 7 and 3 would be 10. So in other words, 10 minus the 3 would equal 7. So that's kind of how that works. You get 60x plus 70 times 10 minus x. And that's basically your expression. That's all they want us to do. It says write a polynomial to represent the distance driven. So we don't know what it equals, but we can simplify this. So we can get 60x plus 70 times 10 is going to be 700 minus 70x. And then we can combine the terms that both have x in them, and 60 minus 70 is negative 10, so we get 700 minus 10x, and this expression would basically represent the distance driven, which is what they were asking us for. So now if you will do it yourself number 5, we will do our last example, which is basically similar to example 4, only this time, in example 4, you had a monomial being multiplied by a trinomial. But now we have a trinomial and a binomial. So basically it's kind of like the whole FOIL thing, but it gets, really crazy. So I want to do this again. I'm going to slow down a little bit, and I'm going to start with n squared times n. So basically each of these terms has to be multiplied by each of these terms. So it's just a matter of keeping yourself organized. So we're going to go n squared times n plus n squared times 2. So that's n squared times n squared times 2. Now we're going to move on to the 4. So we're going to go plus 4n times n, so 4n times n, plus 4n times 2. Then we have a negative 6. So we're going to go minus 6 times n, and minus 6 times 2. And then we can just simplify each of the steps. So n squared times n is n cubed. N squared times 2 is 2n squared. 4n times n is 4n squared. 4 times 2 is 8n. Minus 6n minus 12. And then our last step is to try to combine any like terms. So we have our n cubed. Then we have 2n squared and 4n squared, which is actually 6n squared. 8n minus 6n is 2n, and then minus 12. So this will be our final answer. So again, it's not very complicated, but you do have to keep track of what you're doing so that you don't miss anything along the way. So now you have to complete do-it-yourself number 6. And once you have completed that, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.